All right, so you've done it. You trained this amazing AI model, you pushed it to production, and predictions are flowing in. Life is good, right? Well, after the launch party's over, there's this nagging question. How do you actually know it's still working right? That's what we're talking about today, building that crucial safety net for your AI with logging and alerting.
And yeah, that really is the heart of the problem, isn't it? See, models don't usually just blow up with a big, obvious error message. No, the real danger is when they fail silently. Maybe the accuracy just dips a little, day by day, or the response time starts to lag, or it starts spitting out weird, nonsensical answers for those rare edge cases. These are the kinds of things that can fly under the radar for weeks, all while quietly chipping away at your users' trust and your bottom line.
So let's dive right in and talk about this exact issue, what we call the silent failure problem. It's this really sneaky thing that can happen where even a perfectly built model starts to go off the rails and you don't hear a peep. And this right here, this is the absolute worst case scenario. It's when your users become your QA team. Just think about it. Your recommendation engine starts suggesting completely random stuff, you're losing sales. Or your fraud detection model starts blocking perfectly good customers, you're losing trust. The damage is already done, long before you see that angry tweet or get a flood of support tickets.
And look, these silent problems come in all shapes and sizes. It's not just about the model getting the answer wrong. You could be getting 500 errors from your API. The model isn't even responding. Or maybe you're seeing latency spikes. I mean, if a response suddenly takes over 500 milliseconds, that's an eternity online. People will just believe. And then you've got the sneakiest one of all, performance drift. That slow, gradual decline in accuracy that's almost impossible to notice with the naked eye.
Okay, so how do we even begin to fight back against this stuff? Well, it starts with putting on our detective hat. And what does every good detective need? Clues. That's exactly what logging is for. It's all about gathering the evidence, the clues, to what's really happening with our model.
So what is logging really? At its core, it's just writing things down. Seriously. It's about creating a super detailed, time-stamped diary of everything your system does. Every single API request, every prediction it makes, every little error, it all gets recorded. This log file becomes your go-to source of truth whenever you need to figure out what the heck happened.
And having this record is just incredibly powerful. It's not just for when things completely break. You can dig into these logs to find the root cause of those subtle problems. You can track things like latency over time, and you can even spot the very first signs of model drift. Plus, in a lot of fields, these logs are non-negotiable for audits and compliance, just to prove your system is doing what you say it's doing.
So to get that complete picture, we need a few different kinds of clues, right? We've got our input logs, which tell us what data is coming in. Prediction logs, which show us what the model is spitting out. Of course, error logs for when things go wrong, and latency logs to make sure it's fast. And this is a big one, feature logs, which are key for watching out for that data drift. You put them all together, and you get a complete health report for your model.
Now, I know what you might be thinking. This sounds complicated, but honestly, getting started is surprisingly simple. Like in Python, you can just use the built-in logging library. Basic config is basically you telling the code, hey, start a new file and write down everything that happens. Then you just sprinkle in logging.info to note down the good stuff, like a successful prediction. And when things go sideways, logging.error is there to capture all the gory details you'll need to figure out what went wrong.
All right, so we're logging, we're gathering all these amazing clues. But think about it. A detective who just sits on a pile of evidence and never does anything isn't going to solve the case, right? That's where the second piece of our puzzle comes in, alerting. This is our alarm system.
So, what is alerting? It's basically an automated system that's constantly, 24/7, reading through your logs. The second it spots something that looks off, something that doesn't fit the pattern, bam, it sends a notification to the right people. It's what turns all that passive data collection into immediate, real-world action. But here's the thing, you can't just have alerts for everything. A bad alert is worse than no alert. A good alerting system follows these 5 rules. First, it's got to be fast. You need to know before your users do. Second, it has to be accurate. If you're constantly getting false alarms, you're just going to start ignoring them. That's alert fatigue, and it's a real problem. Your alerts also need to be actionable, meaning they tell you what's wrong so you can actually fix it. And finally, they've got to be prioritized and sent to the right people, so your team knows if it's a drop-everything kind of fire or just something to look at later.
So what kind of stuff are we talking about here? Well, think about setting some thresholds. Like if your API failure rate spikes over 5%, yeah, you definitely want an alert for that. Or if latency creeps past 300 milliseconds, that directly impacts your users.
And of course, something like a 10% drop in accuracy or any sign of unauthorized access, that should trigger a 5-alarm fire, high-priority alert, no question.
Okay, so we have our detective, that's logging, and we have our early warning system, that's alerting. Now let's put it all together and see how this complete pipeline actually works to keep your model safe.
And the process is actually pretty straightforward when you break it down. Step 1, a request comes into your model. Simple enough. Step 2, your system logs everything about that request. The input, the prediction, the latency, the whole shebang. Step 3, this is where the magic happens. A monitoring engine is watching those logs in real time, looking for anything that matches your alert rules. And boom! Step 4, if it finds a match, a notification gets fired off to your team instantly, whether that's on Slack, PagerDuty, or email.
And the good news is you don't have to build this all from scratch. There's a whole ecosystem of awesome tools out there. For handling massive amounts of logs, you've got things like the ELK stack. For the monitoring part, a ton of people use the open source tool Prometheus. And then for the actual alerting and making sure the right person gets woken up at 3 a.m., tools like PagerDuty are pretty much the gold standard.
All right, so we've covered the what and the how. For this last part, let's get really practical and talk about how to do this right. Let's go over some key best practices and, just as important, some common mistakes you'll want to avoid. Okay, so let's look at a few common mistakes and how to fix them. First, don't just log messy, unstructured text. That's a nightmare to search through. Instead, use structured logs, like JSON. It makes everything a million times easier to analyze. Another big one, don't have every alert scream at you with the same urgency. Set clear severity levels, P1 for the house is on fire, down to P4 for, hey, you should probably look at this sometime this week. And maybe the most important thing, have a playbook. Don't just get an alert and panic. Know what the next step is. Is it a manual fix, or maybe it's something cool like an automated trigger to retrain the model?
So if we boil this all down, it's pretty simple. Logging is all about knowing what's going on. Alerting is about reacting before things get really bad. And when you combine them, what you really get is monitoring, that continuous, bird's-eye view of your system's health.
And this quote just says it all, doesn't it? A model is only as good as its monitoring system. I mean, you can have the smartest, most accurate model on the planet, but if you're flying blind, if you don't know what it's doing or when it's breaking, then you can't really call it reliable, can you?
And that's really the bottom line here. For any serious, real-world AI system, logging and alerting aren't just nice-to-haves. They're not optional extras. They are absolutely mandatory if you want to build something that's actually reliable, trustworthy, and ready for the real world.
So I'll just leave you with this one last question to think about for your own projects. Your model seems like it's working great right now, but without those eyes and ears that logging and alerting give you, are you really sure it's reliable? Think about it. Thanks for tuning in.